this is what's on the horizon. Okay, a new set of science standards. Has anyone, what do you know about the standards? Has anyone heard about the process or what they've used to develop the standards?
They're more aligned with the national curriculum.
More aligned with the national science standards? All right, well, hopefully this will be helpful because the second draft of the standards is going to be released in January. And they want feedback. It's been released, it was released in May. They got a lot of feedback and they changed 90% of the standards. So they're listening. Okay, they need input from elementary school teachers. They've not gotten a lot of input from elementary school teachers. They've gotten input from secondary teachers, but they want our input. So the second and final draft of the standards is scheduled to be released in January. And you can go to the website and you can pull the standards up and you can give them feedback. You can give them feedback, and I'll go through everything, but that's just something that they've been talking about. It's part, it's where they are in the process of developing the standards and releasing the standards to states. This is what the standards are based on. They're based on the K-12 framework for science. There is a free download. You have these slides. You can go to that website. You can download the framework. I haven't read the entire framework. I've read parts of it. It is lengthy, 300, 350 pages. So that's what the standards are based on. And it says at the top of the slide that the framework gives a vision for science education. Science for all students, coherent learning. We're working on, and I think we do a lot of that now. Like I teach 5th grade science. And I know what I'm teaching in my classroom right now, other teachers will build on what I'm going through with the kids right now. Each standard is divided into three dimensions. So there are 3 dimensions that are combined together to make each standard. So you have dimension 1 is practices, behaviors of scientists. Okay, dimension 2, cross-cutting concepts. Okay, concepts that you can apply in all of the different domains. And then you have the content, which we spend a lot of time teaching the content. That's what the kids are tested on. And so I understand that. That's what I do in my classroom. And they're also going to be tested on practices. That's what they're telling us. Now, all of this may change. I don't know how Georgia is going to put all of this together and give it to us. But what they're telling us is that they are going to test the kids on practices, which they're not currently doing. We have all those nature of science standards. None of those standards are tested. Hey, the content is tested. So I spend a lot of time teaching content, just like everybody else. Yeah, but I really try to teach the content through different hands-on activities, and as they're doing those activities, okay, they're practicing the behaviors of scientists. They're doing things that scientists do. But each standard is a combination of these 3 dimensions. Okay, this is the current phase, and this is what I was just talking about. Okay, the second and final draft is scheduled to be released in January. Okay, they're encouraging anyone that's interested to give them feedback. Okay, and that feedback will go to the lead states, and Georgia is one of the lead states, and the writers of the standards. Okay, what impressed me is that 90% of the standards have been changed after they were released in May. That tells me that they're listening. They're listening. Hey, if they weren't changed, if they didn't make any adjustments, well, what's the point of giving feedback if you're not going to listen to us? But 90% was changed after they were released in May. Okay. At the bottom of the slide is the other parts of the timeline. Okay, the standards are scheduled to be released to the states in the fall of next year, and then implementation and testing 2015. So we have time. We have time. And what I'm doing, what I would suggest, is looking at some of the things that you're doing in your classroom in the second semester. Hey, how can I do some things differently to get ready for these standards? And I'm going to show you a model that you can use to get ready for the standards. Okay, this is just another slide showing you what I was talking about. So phase 1 is done, framework for science. Okay, the standards are based on that framework. Phase 2, that's what they're working on now, putting the standards together. Standards are going to be released to the states, and these are all the things that we're going to work on. Okay, assessments in curriculum instruction, professional development. All right, this model, and I use this quite a bit. I take Ames activities, okay, and I use the Ames activities or whatever else I want to do with the kids, and I use this model to put everything together. Okay, this is a model that will help you get ready for the next generation standards. And if you look at the model, okay, it starts with engage, then explore, explain, elaborate, evaluate. Okay, I don't always have time for elaborate. If I have time, I may do something else with them so that we can go deeper into what we were talking about, but I don't always have time for that. Okay, I always do something at the beginning to get them interested in what we're going to do, and then I give them time to explore, and then we talk about what they figured out, and then I give them some time. To respond. Okay, I did have them do something in their journal, and then I could evaluate whether or not they figured out what I was hoping they would figure out. And here's just some more information about each of the parts of the model. Okay, engage, just generate interest, get them excited about what you're going to do in class, what they're going to be doing. Okay, explore, hands-on with guidance. And I know sometimes when you hear hands-on, you just, throw a bunch of stuff at them and you let them do whatever. And when we do hands-on in my room, it's guided discovery. I'm helping them, I'm guiding them. Because there's something that I want them to figure out from the activity. Okay? Explain, giving them time to share their observations, what they figured out from their observations. Elaborate, just giving them other opportunities to apply what they figured out from the activity. And then evaluate as assessment. I know in other sessions we talked about the question, claims, and evidence model. That's something that you can do to evaluate whether or not they figured out what you were hoping they would figure out. All right, I'm going to give you all the goldfish. This is an activity I did with my kids 2 weeks ago. And we're still, and I'll explain all of this, but let me pass these out, and I'll tell you what I want you to do. Let's hope I have enough. I have 6, so some of y'all may need some of y'all may need to combine. If y'all would combine with them, that'd be awesome. All right, this is an Ames activity. Okay, this is an Ames activity. This is, we did this activity a couple of weeks ago. For the last several weeks, we've been trying to train the goldfish to come to the top of the water when we tell them to. And so we're gonna, I'm gonna take them home over the break. I'm gonna continue to train them, and hopefully when they come back, the kids come back from the break, they'll either be trained or they can continue to help me train them. But I do these activities, like the activities I'm doing with the goldfish, helps them figure out the difference between inherited and learned. So I'm going to do the activity that helped them figure out that the breathing behaviors of a fish are inherited behavior. And before I did this activity, we did some other activities. We talked about inherited traits, traits that are passed from parents to offspring. We talked about all of that. So they had some background. We did this activity, and then after this activity, after breathing behaviors, we started training the goldfish. And that's what we've been working on for the last week and a half. And I do it at the beginning of every class. Each class has a goldfish. They name their goldfish. They're attached to their goldfish. So they get excited about it at the beginning of class. I spin a wheel. Each student has a number, and they are hoping that the wheel lands on their number. I call it the wheel of science, which is a little cheesy, but they really like that. You know, I teach fifth graders, that's why I teach elementary school, because they get excited about things like that. All right, this is how I've taken the activity, okay, and adapted it to the 5E learning cycle. Okay, so at the beginning, and I'll kind of do some of this with you, okay, at the beginning of before I start the activity, before they explore, okay, I throw out a key question, and then they work on something in groups. So what I want you to do, I want you to watch the fish swim around for a couple of minutes, and then we can talk about what your fish did. So just take a couple of minutes. That way you don't have to listen to me talk the whole time. Just watch your fish swim around, and we can talk about what happened. Believe it or not. All right. So tell me, what did you see your fish doing? Okay, swimming. What else? Trying to get out.
Nibbling on the sides.
Okay, nibbling on the sides of the container.
Ours knows that Jim is a fisherman.
So he's scared of Jim. He's trying to stay away from Jim. All right, anything else?
Ours is going to the top. He's already trained.
So your fish is trained. Anything else?
He's a gifted fish.
So he qualified to challenge. You know, you'd be surprised. All right, anything else? No one saw the fish opening and closing its mouth? Okay, I didn't hear that. Okay, that's what I hope the kids see when they watch their fish swim around. And then we talk about what the fish is doing, we talk about gills, and that's one of the key questions for this activity. And this is in this activity, all of the information is in the packet that was in the center of your table. But one of the key questions for the activity, how does the fish breathe? So usually one of the kids in my class says, hey, Mr. Amerman, the fish is opening and closing its mouth. And so we talk about it. We talk about how fish need air, need oxygen just like we do, and then we talk about gills. That's one of the differences between fish and other animals. And so this gets them excited about the activity. And if you look at your handout or your screen, and the next part of the learning cycle, explore. And so what I tell them to do is watch the fish swim around for 30 seconds and count the number of times it opens and closes its mouth. Okay, we do that 3 times, and then they figure out the average. And then we change their environment. I know it sounds cruel. Okay, but the kids move the bowl around, they move the water around, the fish get excited, so their breathing rate changes. And then they put a bag of ice in the water, and the water cools down, and their breathing rate changes. And I promise you that no fish have been hurt in this activity. I promise you, no fish have been hurt. If I thought I was going to hurt the fish, I wouldn't do that. I wouldn't do this activity because the kids would get upset if one of the fish got hurt. Okay, so if you look at the handouts, this is the activity sheet that the kids have. Okay, you can see the different treasure chests. Because the other key question for this activity, how does the breathing rate of a fish change when its environment changes? Okay, so after talking about the standards, behaviors of scientists, okay, these are things that scientists do. They make observations, they draw conclusions. So if you're not doing the hands-on, you're teaching the content from the textbook, they're going to have trouble figuring out what scientists do. They're going to have trouble picking up practices, behaviors of scientists. Okay, so I'm going to give you some time. I want you to do it just once so you can kind of get an idea of how the activity works. So I'm going to get my phone, I'm going to pull my stopwatch up, which I tell the kids not to tell Miss Murphy because she doesn't want cell phones out in class. I'm sure your principals feel the same way. Okay, so let me pull up my stopwatch, and I want you to watch the fish swim around for 30 seconds count the number of times, the fish opens and closes its mouth. What I say to the kids, the number of times it gulps the water. Okay, that helps them to understand what I'm talking about. All right, you ready? 30 seconds. And you would be surprised, when I do this activity, you hear a pin drop in my room. The kids are laying on their desk, they're watching that fish swim around. It's crazy. You know, I need to take a video and throw it up somewhere because they really, really enjoy this activity. All right, here we go. You ready, Mr. Sutherland? All right, ready, set, count. Just like my classroom. All right, stop. All right, how many breaths? 48. Someone else, how many breaths? 42. 42. Anyone else?
I was dying.
We have 7 times to go with mouth.
7?
7 times.
Should be more than that.
Ours did not open it.
Well, it's freely. What's funny is the normal breathing rate is between 65 and 75 breaths, which is crazy. So when my kids do it, that's all right. I'm trying to show you how the activity works. Not a big deal. The water's cold. I pulled them out of the tank this morning. I turned the heat on in the car because I wanted to warm the water up. But they're cold, so they're not breathing. They're not taking as many breaths as they normally would. Okay, but if you look at this handout, we do this 3 times. And then the kids figure out the average number. The average number of breaths their fish took in its normal environment. And then we change their environment. We move the water around. We put some ice in the water, lower the temperature of the water. Okay, now if you look at this slide, the next part of the next step in the learning cycle, explain. Also in your pack, there's a graph. Okay, so after they have gathered their data, after they've gathered data, they graph their data. Okay, and if you look, the graph has already been set up. Depending on the number of breaths, okay, you may have to change the scale. Okay, I changed the scale in all of my classes. The kids helped me figure that out. So they graph the average number of breaths. And then they look at the graph and they can draw conclusions. Hey, look, Mr. Amerman, their breathing rate went up when they were excited. Their breathing rate went down when the temperature of the water went down. So they're gathering data, they're graphing their data, and they're drawing conclusions from their data. Those are things that scientists do. Those are things that scientists do. Okay, and then if you look at elaborate, okay, after they have written in their journal, because most of the time I do evaluate and then elaborate. After they have, answered some questions in their journal, wrote down what they figured out from their graph. Okay, and most of them, I would say most of my class figured out that the breathing behaviors of a fish are inherited behavior. It's inherited behavior. It's a behavior that's been passed down from parents. And after we looked at the graphs and everyone, after they saw that all of the fish did the same thing, okay, that's evidence. This is inherited. This is inherited. And then their parents didn't teach them. Their parents didn't teach them how to breathe. That's something they were born with. And their parents didn't teach them when they got excited to take more breaths. So there's just a lot of really good conversation, a lot of rich conversation that helped them figure out that what they saw, the breathing behavior of a fish, is inherited. So after they've written about that in their science journal, and I have them keep a vocabulary foldable for my genetics unit. So they go to that foldable and they write down their own definition for inherited. And then we, after they've shared, okay, give me some other examples of inherited behavior. I had several students, migration. Okay, some animals are born to move. They know a lot about monarch butterflies. And so that always is one of the examples that they throw out. I had a student this year, Mr. Amerman, when I touch a worm, the worm kind of pulls back. That's inherited behavior. So we've already talked about inherited traits, and then we talk about, different behaviors that are inherited from parents. And then the next part of this activity, is training the goldfish to learn behavior. So what we do with the goldfish over a couple of weeks helps the kids figure out the difference between inherited and learned. And so I've taken Ames activities, and I've just, moved some things around, and I've adapted the activities to this model. Okay? Now let me show you the tie-in to the next generation standards. Okay, here's the content. Okay, here's the standard. And I don't know, I've looked at the graphic, and there's a lot of content that's moving around. So, I'm teaching, genetics and inherit and learn. The first draft has all of that in 4th grade. And then I'm picking some things up from 4th grade. That is if I stay in 5th. I'll pick some standards up from 4th grade. But there's the standard. And then if you look at the practices, okay, argument, engaging in an argument from evidence. Okay, they collected data, they graphed their data, they drew conclusions for their data. So they're saying, well, this is what I think. Well, prove it. Prove it. And they have they can look at their graph and say, this is what it says on my graph. This is why I'm saying this. Okay, and those are things that scientists do. And then cross-cutting concepts cause and effect. Okay, if you change a fish's environment, something is going to happen to its breathing rate. Okay, so that's the cross-cutting concept. Those are concepts that you should be using in all the different domains: life science, earth science, physical science. Okay, and the standards go through all of that. So if you look at your packet, if you look at, I believe it's not the last page, it's the page right after the PowerPoint slides. Okay, here's part of the draft. The draft of the standards that was released in May. And I know when you look at it, it's like, wow, that's a lot of information. It looks it's extremely confusing. And if you go to the website, okay, they have a short video explaining how to read the standards. Okay, but at the top you have the standard. The top you have the standard. And then at the bottom, there's different boxes. They call them foundation boxes. And you have the practices, and it says science and engineering practices. Okay, we've been talking about STEM for a long time. All of those different things that engineers do. And that's part of the practices. That's part of that dimension of the science standards. And then in the middle, you have the standards, the core ideas. And then on the right, you have the cross-cutting concepts. And if you look at those foundation boxes, you can see letters. And those letters match the standards that are at the top. And at the bottom, you have connections to Common Core. The Common Core standards that, we've been talking about for the last couple of years. And we have time. We have time. And implementation and testing is not until 2015. So, what I encourage you to do is take a look at that second draft. Okay, give the lead states, give the writer some feedback. Throw in your 2 cents. I know my wife has. She teaches biology at the high school, and what they're trying to do, what they want to do. And I don't know if George is going to go along with this or not. I don't know. I'm sure there's going to be a lot of changes before we have our hands on the standards. But my wife teaches biology, so they want the science teachers at the high school level to teach a little bit of everything. And so, she's not too happy about that. So she shared that. And I don't know if that's going to change or not. And I don't know how they're going to do middle school. When I looked at the draft, middle school, it's like you have life science, you have the domains. But they haven't said, hey, 6th grade is going to do this, or 7th grade is going to do this, or 8th grade is going to do this. And now the elementary standards, they're organized by grade level. And so when I look at the 5th grade standards, I can see what I'm going to pick up from other grade levels, and I can see what I'm giving up to other grade levels. Okay, but I encourage you, when that draft is released, get on there and take a look at it. Take a look at it. And then look at some of the activities you're going to do in the second semester. And try to use this model. Okay, And I know hands-on, I know it's, you know, I was laughing on the way here. I had fish in my cart, I have 100 mason jars. Okay? I grew borax crystals with my kids before we get out for the break, and so I took the jars home and I cleaned them out last night. I'm like, I must be crazy getting all this stuff together. Hey, but the kids, like when they pulled their snowflakes out yesterday, really excited. We got to talk about how all of that works, and they were listening, and you know, this activity, they get so excited about it. So that the hands-on is what makes science interesting. The hands-on is what they enjoy. And that's one of the reasons why, you know, I enjoy teaching science. They get excited about coming to my class. They get excited about coming to my class. So take a look at that draft. Look at this model and try to rework some of your activities using this model. And that will help you. This model will help you get ready for the standards. And if you go to their website, there's a place in the upper right-hand corner where you can put your email address, and they will send updates. And they'll send you an email saying, hey, the draft has been released. Go to our website, look at the draft, give us some feedback. Okay? The website is not in this packet. Actually, I shouldn't say that. I just lied to you. I apologize. If you look at the slides, okay, on the front page, thank you, Kathy. If you look, on the back of the front page, okay, right below the diagram at the bottom is the website. Please take a look at the draft. I can't emphasize that enough. This is a big deal. And this is Common Core for science. This is Common Core for science. And what I really appreciate these standards are being put together by states. It's not the federal government saying, hey, you're going to do this. Okay, it's not like No Child Left Behind. Okay, states are putting this together. Georgia is one of the lead states. Okay, there's a person in Atlanta, okay, that is over everything that's going on. Okay, there's writers from each of the lead states. So, there's some people at the DOE that you can email and say, hey, this is what I'm thinking, this is what I'm concerned about. So please get involved in this. They're listening. And again, try to use this model, try to rework some activities that you really enjoy, that the kids enjoy, okay, and rework them using this model. This will help you get ready for the next generation science standards. Okay, I appreciate it. Thank you so much for listening and giving me some time to talk about all of this.